Okay, so let's start the topic about the holomorphic covering space. Okay, so let's start with some definition. I need to talk here. Okay. Okay, so definition. A holomorphic covering space covering space or a one-dimensional complex covering manifold. Or for x hat connected a covering Riemann surface of a complex so remember that the complex manifold is that complex one manifold X is a covering space in gamma from x hat to x. Which is x hat is a complex one manifold and the mapping gamma is locally holomorphic. Okay, so this is the definition of holomorphic covering space. And then I will introduce the definition of complex manifold, like locally holomorphic. So you can find it in any standard classical textbook. Okay. So one thing to know that if you have a connected complex manifold, it is called a Riemann surface. Okay. Okay, so now so in other words, each point each point in X okay, has a connected neighborhood U such that this gamma as each connected component of gamma inverse U biholomorphically onto U. Okay. Yeah, because yeah, because for this manifold, you have the local trivialization, right? So for the local trivialization, because it's a local homomorphism, so because it's this Rn is like locally connected, so you can find a connected set that maps onto the point. So that's sort of a connected neighborhood, and then because it's an evenly covered, right? So yeah, because it's evenly covered, so yeah, because evenly covered, you take first you can first take a evenly covered neighborhood, and then you map that neighborhood in Rn, and then because Rn locally connected, you take a connected set, and then you map it back. That becomes the connected neighborhood U, and then this gamma inverse U is yeah, locally biholomorphic. Yeah. Okay, so and then the holomorphic covering space gamma from okay, so gamma equivalent to a holomorphic a covering space sorry, the wording here, yeah, there's some definition here. Gamma check, okay, this is letter check, from x check to this x if there exists a biholomorphism phi from x check to x check that is a lifting of gamma check. Okay, so sorry, yeah, so there is a biholomorphism. Yeah, sorry, I kind of forgot that. Yeah, I'm kind of yeah. So I maybe call the definition for biholomorphism between is that is so for complex. Yeah, so for the biholomorphism in C, you have this map as a bijection. Wait. It's a bijection, and then is wait. Wait. Let me recall. So it should be a bijection, and then yeah, I think it's let me check. Sorry. Okay, it's a holomorphic function mapping open set omega directly onto an open set. Okay, and then the inverse function is holomorphic. Okay. Yeah, so basically it's a bijection. Yeah, it's a bijection, and then it's a it's a holomorphic function, and it's a bijection, and then the inverse function is also holomorphic. Yeah, so this is the definition of biholomorphism. Yeah, and then yeah. So for Riemann surf, let me see. Yeah, so if you have a complex manifold, right, or Riemann surface, the biholomorphism for that is I think it's like we have the chart, right? Yeah, so yeah, we have it. yeah, so so it's like you have this chart that's pulled back and then compose diagonal. Okay. The holomorphic function and then okay. Okay, I think I think the definition for let me just double check. Sorry. So you first define a holomorphism by you basically define the holomorphism by from one space to another, right? By the saying that wait, I forgot. Yeah, so okay, so you can check for so I won't discuss it right now, okay, because you can find it on any standard textbook, okay. Yeah, sorry. Okay, so let me just say, okay, let me just continue. Okay. So where am I? Okay, so there is a backbone holomorphism that is a lifting. Okay, that's a lifting of this gamma check. Okay. Okay, so let me IE phi is a fiber preserving by holomorphism. Okay, so now a simply connected holomorphic covering space holomorphic covering space gamma from x tilde to x of a Riemann surface. Is also called the holomorphic universal covering space. I'll probably double check with the definition here. So, so it's very important. Universal covering space. Okay, or universal covering Riemann surface. Okay. Okay, remark. Holomorphic. Oh, okay. Equivalence of coverings is an equivalence relation. Okay. Let's so let's see. Maybe okay. Maybe I'll leave it to you to check. Okay. So check exercise. Okay. And then okay. Let's okay. Let's take the following proposition. Okay. Let me see. Okay, so let's take the proposition. Okay. I think I need a lot of exercise. Okay, so now proposition. Let X be a complex one manifold, and that gamma from x to x, x hat to x be a topological colored space, or be a colored space. Okay. Coloring space. First, if this x hat is a complex one manifold, and this gamma is holomorphic, then have this gamma from x hat to x is a holomorphic covering space. Okay, so let's start the proof. So, okay. And for part B, in general, there is a unique holomorphic structure of x hat with respect to which is gamma from x hat to x is a holomorphic covering space. Okay. Okay. Okay, so let's start with proof. Okay, so for part A, so so part A follows from the holomorphic inverse function theorem. Okay, so let's see why it follows from the inverse function theorem. So, okay, so the holomorphic inverse function theorem says that if you have a holomorphic function that's with derivative is not equal to 0, at a point, then it's a locally baffled Morrison. Right. Sorry, let me see. So, so okay, so there's a holomorphic vertical zero for Riemann surface. Okay, so basically you let phi from xy be a holomorphic mapping of Riemann surfaces. Okay, so basically okay, I'll state it here. Okay, maybe I just say it. Okay, so if phi from xy be a holomorphic mapping of Riemann surfaces, so if you take any point px, and then this phi, yeah. So this here, if you have this phi from x to y be a yeah, so yeah, be a holomorphic mapping of Riemann surfaces. And then that and then that a equals, okay, so a, so if the p is the x, and then you have this phi if I push forward at p is not equal to 0, then yeah. Okay, then phi maps some neighborhood of p by holomorphically is the holomorphic inverse function theorem for Riemann surface. Okay, of p by holomorphically onto onto a neighborhood of Q, which being defined as phi p, in particular, if f is a holomorphic function, on a neighborhood of a point Px, and then dfp not equal to 0, then this u f restricted on this u is a local holomorphic coordinate. Neighborhood, sorry. Neighborhood for some neighborhood u of p. Okay. This is the first part, and then okay. So second part says, okay, if phi is 1 to 1, then phi maps x by holomorphically on the opposite phi of x of y. Okay, so this is part B. Okay. Okay, so I won't prove this theorem. Okay, so I'll just say here. Okay, and then let's see why this A follows from this one. So let me see. If this x hat is a complex one manifold and y is gamma is holomorphic, then this is a holomorphic common space. Okay, so our goal is to show that this gamma is a holomorphic covering space, right? So okay, so to show that it's a holomorphic covering space, so let's see what we need here. Okay, so this X is a compact manifold, one manifold, okay. Okay, yes, and then X hat is a compact one manifold. Yes, and then the mapping gamma is locally biholomorphic. Oh, sorry, it's a covering space. Okay. Okay. So it's a covering space. Okay, so all we need to show that this gamma is biholomorphic, right? It's locally biholomorphic. Okay. Okay, so let's see why this gamma is locally biholomorphic. Okay, we know that this gamma is holomorphic. I think we want to show that these okay. Gamma is locally biholomorphic. Okay, so basically we want to show that I think what we can do is that because we can do the local coordinate, right? Yeah, I think the thing is that here you have this gamma is a covering space, right? So for covering space, you have this evenly covered set. So for evenly covered set, the gamma retrieved on the evenly covered set should be local homomorphism. Should be should be homomorphism. And then since gamma is holomorphic, then I mixed up. So yeah, so since gamma is holomorphic, then we can take the wait. Okay, yeah, I think yeah, I think time is up now. Okay, so I will leave it to you as an exercise for this one. Okay. Yeah. So I think the idea is that you can somehow play with definition that you construct like the inverse, and then you use the inverse to show that. Yeah. Because you already have the local like homomorphism, right? Okay, you have a bijection map basically. Yeah. You have bijection, and then it's the it's holomorphic. So I think maybe you have that, right? Maybe you have that. Sorry. Yeah. Okay. All right. So yeah, let's continue next time. Okay. Next time I will try to show the part B, maybe.
Yeah. Or, yeah, I'll show part B. Okay, I'll show part B can start. Okay.